Base theories. Compounds can be divided into acids, bases, and salts by Robert Boyle on the basis of their properties. To explain the nature of acids and bases, different theories have been proposed by different scientists. The important theories are: one is Arrhenius theory, second one Bronsted-Lowry theory, third one Lewis acid-base theory. Now, today we discuss one of the theory of Arrhenius acid-base theory. After the end of this period, you would be able to understanding Arrhenius concept of acids, bases, salt, and limitations of Arrhenius acid-base theory. This Arrhenius acid-base theory to introduced in 1884. 1884, Arrhenius proposed that salt dissolved in water into positive and negative ions. He further extended his theory in 1887 to acids and bases. Arrhenius to explain about acid. What is acid? A substance which gives H plus ions when dissolved in water is called acid. A substance which gives H plus ions when dissolved in water is called an acid. Substances which are dissociated in aqueous solution to give hydrogen ion, that is H plus ion, are called acids. Substances which are dissociated in aqueous solution to give hydrogen ion are called acids. Acids, like example, completely or partially dissociated in aqueous solution, it produces H plus ions, like some example HCl, H2SO4, HNO3, CH3COOH. These are some acids. Bases. What is base? A substance which gives hydroxyl ions when dissolved in water is called a base. A substance which gives hydroxyl ions when dissolved in water is called a base. Substance which dissociated in aqueous solution to give hydroxyl ion are called base. Substance which gives hydroxyl ions when dissolved in water is called a base. Substance which dissociated in aqueous solution to give hydroxyl ions are called base, like sodium hydroxide, potassium hydroxide, magnesium hydroxide, aluminum hydroxides are bases. Like Arrhenius acid HA, it is dissociated in aqueous solution to form H plus and A minus. It produces H plus ion concentration increases in water, so it is act as acid. Base BOH. These base are BOH. dissolve in water, it produces B plus OH minus. The concentration of OH minus ions increases in water, so this dissolved substance is act as base. The substance dissociated in aqueous solution, it increases H plus ion concentration is called acid. Substance dissociated in aqueous solution, it produces hydroxyl ions is called base. Arrhenius acid, Arrhenius base. Like example, HCl dissolve in water to produce H plus Cl minus. So this HCl produces H plus ions in water is called Arrhenius acid. H2SO4 sulfuric acid. It dissolve in water, it produce H plus ion concentration in aqueous solution. So H2SO4 act as acid. H2SO4 gives rise to H plus SO4 minus 2. So these H2SO4 act as Lewis acid. Sodium hydroxide dissolve in water to produce Na plus OH minus. This sodium hydroxide dissolve in water, it produces OH minus ion concentration in aqueous solution. So this sodium hydroxide act as base. Ammonium hydroxide. This ammonium hydroxide dissolve in water, it produces ammonium ions plus OH minus ions. Ammonium hydroxide NH4OH gives rise NH4 plus OH minus. These OH minus ion concentration increases substance in aqueous solutions are called Arrhenius base. Neutralization reaction. What is neutralization? The reaction between an acid and base is known as neutralization. The reaction between acid and base known as neutralization reaction. The reaction between acid and base to form salt and water is called neutralization. During neutralization, H plus and OH minus ion combine to form water. Neutralization reaction. The reaction between acid and base to form salt and water is called neutralization. During neutralization, H plus and OH minus ions combine to form water. Like example, acid HCl, base NaOH react together NaCl plus H2O, NaCl salt plus water. Example, NaOH plus HCl, NaOH Arrhenius base, HCl Arrhenius acid react together to form NaCl plus H2O, salt plus water. Actually, free H plus ions does not exist in water. These H plus ions then combined with solvent molecule that is hydrated to form hydronium ion. This H plus ion does not form in free ions. These H plus ions interact with water molecule to form hydronium ions. H plus H2O gives rise H3O plus. Strength of acids and bases. The strength of acids and bases depends on rate of dissociation and number of ions produced. The strength of acids and bases depends on the rate of dissociation and number of ion produces. Strong acid, strong base are completely dissociated and produce more number of H plus and OH minus ions. Weak acid and weak base partially dissociated to produce less number of H plus and OH minus ions in aqueous solution. Strong acid. The acids which dissociated completely to give more number of H plus ions. The acids which dissociate completely to give more number of H plus ions are called strong acid. For example, HCl, H2SO4, HNO3, HClO4. The acids which dissociated completely to give more number of ions are called strong acid. Strong base. The base which dissociate completely to give more number of hydroxyl ions are called strong base. The base which dissociate completely to give more number of hydroxyl ions are called strong base, like sodium hydroxide, potassium hydroxide. Weak acids. The acids which dissociate partially and give less number of ions are called weak base. The acids which dissociate partially and give less number of ions are called weak acids. CH3COOH, HCOOH, H2CO3, so on. Weak bases. The bases which dissociate partially and give less number of hydroxyl ions are called weak bases. Ammonium hydroxide, calcium hydroxide, aluminum hydroxide. The bases which dissociated partially and gives less number of hydroxyl ions are called weak bases. These are strength of acids and bases. The ionization of acid in aqueous solution should be represented as ionization. Formation of charged particle from molecules are called ionization of acid in aqueous solution should be represented as HCl dissolve in water. It produces H3O plus Cl minus. H3O plus Cl minus. Limitations of Arrhenius concept. It is applicable only to aqueous solution. This theory applicable to only aqueous solution. This theory explains the nature of compound in aqueous solution only, which is dissolve in aqueous solution. Those compounds characters should explain Arrhenius acid base theory. For example, according to Arrhenius theory, HCl is acidic in water. HCl dissolved in water, it produces H plus ions, so HCl is acid. But this theory could not explain about the nature of benzene. This benzene does not dissolve in water, so this compound nature cannot explain Arrhenius theory. This theory explains only the compound which is dissociated in aqueous solution. Those compounds nature can explain Arrhenius acid-base theory. The compound, the concept could not explain the properties of all acids and bases. This theory could not explain the acidic nature and basic nature of compounds without H plus and OH minus ions. Some compounds does not present H plus and OH minus ion. Those compounds act as acidic and basic nature. But according to Arrhenius acid-base theory, substance dissociated, it produces H plus ions or OH minus ions in aqueous solution, either acid or base. But some of the compound without H plus and OH minus ions, these compounds act as acids and bases. It failed to explain acidic nature of aprotic compounds such as SO2, NO2, CO2, P2O5, SO3, N2O5. These all are acids. But these compound does not present H plus ions. But these all are act as acidic nature. Those compound characters cannot explain according to Arrhenius acid-base theory. It failed to explain basic nature of without OH minus ion compounds like ammonia act as basic nature, but according to Arrhenius should not explain these ammonia nature. Sodium carbonate basic nature and calcium oxide, magnesium oxide, these also bases. This theory failed to explain acidic nature of central salts such aluminum trichloride, boron trichloride, boron trifluoride, ferric trichloride. These all are act as acids. But according to Arrhenius theory, this theory should not explain acidic nature of some substance. The H plus ion is exists to H3O plus in aqueous solution. But this theory could not explain the formation of H3O plus ion in aqueous solution. Arrhenius theory could not explain the neutralization reaction between acidic oxides and basic oxides. CO2 acidic oxide, calcium oxide, basic oxide to form calcium carbonate is salt. This reaction should not explain according to Arrhenius acid-base theory. Summary. Acid gives H plus ions in aqueous solution. Base gives hydroxyl ions in aqueous solution. Acid and base combine to form salt fizz. What is Arrhenius acid? Substance which completely or partially dissociated in aqueous solution, it produces H plus ions is called Arrhenius acid. CO2, SO2, SO3, HCl. In this four component HCl dissociated in aqueous solution, it produces H plus ion concentration. So these HCl Arrhenius acid. HCl is correct answer. Which is Arrhenius base substance dissociated in aqueous solution, it produces OH minus ions is called Arrhenius base. Ammonia, calcium oxide, sodium hydroxide, hydrochloric acid. This NaOH produce hydroxyl ions in aqueous solution is called Arrhenius base. NaOH is right answer. Arrhenius failed to explain the acidic nature of carbon dioxide, sulfur dioxide, sulfur trioxide, all the above. Oxides of carbon, sulfur, nitrogens. These compounds characters should not explain according to Arrhenius acid base theory. So answer is all the above. All the above is answer. Frequently asked question about this topic. State and explain Arrhenius theory of acids and bases. Explain neutralization of Arrhenius acid base theory. Explain strength of acids and bases. Write the limitations of Arrhenius acid base theory. These are frequently asked questions about this topic. Thank you once again.